So hello everyone. This video tutorial will learn about the data processing. One small example of Pig Latin data processing will be taught to you, will be learned by you using this particular tutorial. So this data processing will be gone through with the most important and most widely used operators of Pig Latin programming language. And for that, we'll use this example dataset. The name of the dataset is what? It is moviesdata.csv. So this movies underscore data.csv file has this data structure. These are the data it has. It has the ID, yes, of the movie, the name of the movie, and then we have the year of the movie, the rating of the movie, that is 3.2 here, and then we have the, in terms of the seconds, the duration of the movie. Yes, all are separated by comma. So we will see that how data processing using the Pig Latin language can be done for this particular dataset. First, we'll go through with loading the data. This particular movies data.csv to be loaded to the Pig for further execution. Correct. So we'll load the data first. How will load the data? We'll load the data by pig dash x space local. So pig minus x local will start the Unix. If you're executing this pig from the Unix operating system or any Unix or Linux flavor of the operating system, then the local file system will be accessed for that, not HDFS. Keep this thing in mind. We are not going with the pig minus x map reduce. Then the HDFS file system will be accessed. Here we are using what? We are using local file system. Now after that, you are doing what? Grunt greater than sign. So this is the grunt shell is opened. Using this grunt shell, you are storing in a particular variable movie. What you are storing based on this particular command, whatever the output you will get, that will be stored to this movies. Correct, na? To this movies. What you are doing over here, we are loading the data. So you are using the load command, load operator you are using. Loading what? You are loading it this particular file. So it is given inside the single inverted comma. This is in the same directory. So you're not, you don't need to specify the root and then the directory. Same directory, we have movies underscore data.csv. How you're doing it? By using the using pig storage. So using pig storage is the supportive function to the load operator, which will load the data based on this specified the sign. So here in this particular data set, we can see that the data is separated by comma. Correct. Here we have a comma. 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 This data, each and every line, each and every tuple of the data set is separated by a comma. So whenever this comma will appear, that will go to each and every specific schema. So this is the schema. As keyword is used for specifying the schema, right? So in this particular schema, we are providing the value ID, name, year, rating, and duration. For example, one will be into the ID, then next comma will come over here. So next value is this particular name of the movies that will be stored into the field name. Then the next value is 1986 that will be stored into the field year. The rating 3.2 that will be stored to the field rating, and duration will be stored into the rating. Sorry, 7560 will be the seconds of duration that will be stored to the field duration. This way we load it down, load it to the variable movies. Now if you dump the movies, we'll get the same content of this. We'll get the same content. If you dump the movie, dump will print the thing into the front shell. Correct. Now we'll see further operations, further data processing, filtering the data. How will filter the data? For that we have the command filter by. So we'll be using that. Filter by. So filtering what? Filtering the movies. Because these are the movies we loaded right already. So we are filtering that. Filtering what? Movies by rating. By rating greater than 3.5. This is the Boolean condition which we must to provide. Rating is the which particular field name. The fourth field name is rating. ID first, name second, year third, and the rating is the fourth one. So these are the rating. 3.2, 3.8, 4.1, 3.7, 3.4. These are the ratings. So if the ratings is more than 3.4, only those rows will be selected from there, and it will be stored to the variable movies underscore greater underscore than underscore 35. Yes, We are doing some operation over there. This is what? This is the typecasting. Because the rating is greater than 3.5, that will be converted to the float value. So now that you are dumping, if you dump them, then which particular fields will come? Wherever the rating is more than 3.5. So this one will not come. These things will not come. Let me just, this first one will not come, but this one will be displayed. The dump. This one will be this one will be displayed, but this one will not be displayed. If this is rating is more than 3.5, it will be displayed, and these things will not be displayed. So these 4 rows will be there if you execute this thing in the grunt shell. I'll ask you to please do it later. Yes, I'll share this PDF with you in the description of this video. You can get it. Now we'll store the results data. How to store the results data? Store command, store relational operator is used for that. That which particular thing we're getting, these things we got na, is greater than 35, that we are storing into. So store and into comes together, the part of the relational operator execution. So store into, where we are creating a file my underscore movie. Yes, it stores the result in a local file system directory named my movies. So it will be a file which will be created in your local file system. Peak specific movies underscore getter underscore 35 will be specific to peak. This will be stored, my underscore movies will be stored into the, where? Into your own file system. How to display the result? You have to use the cat command for that. Cat, then my underscore movies, and their part file will be there, that you have to display by using that. Now the load command specifies only the column names. We can modify the statement as follows to include the data type into the columns. How? See, you're getting the complete over here. Getting the complete over here. You're loading this same thing, right? Like the last time we loaded, right? But here you're specifying that which particular column values it can store. So ID can store only integer, name can store only character, array, year can store only integer, rating can store only double, and duration can store only integer. You can specify the schema in this way also. Now we'll use the filters. This filter used by using the same command filter by, and here you can give the different kind of boolean expressions. Here the boolean logic you are giving is that the year should be, the movies year should be more than 1990, that is 1991 onward, till less than 1995, so till 1994. So 1991 to 1994, whatever the things will be there into the movies. What is the movies? Right, is the movies, right? That is all the things are provided there. So that will be fetched by that, the movies we bring the before one line, correct? So those movies will be only displayed, the movies between 90 or underscore 94. So which movies will be coming for that? Greater than 99, this one will be displayed. This 99 are also display. These two lines will be displayed for sure, okay? But this part, now we are doing some other filtering with the alphabet D. Whatever the movies are started, we want to filter those. Filter by, yes. Now you can see that filter movies is the, this is the output which you got over here. Potential we have loaded actually. So movies by name, name is the name of the field, correct? Now a new thing you are seeing, matches. Matches is the syntax for regular expression matching. Matches, now the Java like regular expression you have to provide. D dot asterisk. So after D, whatever the values are there, that should supposed to match. Stored into the movies underscore starting underscore with yes. Yes, if the movies that have the greater duration more than 2 hours, if you want to filter, then filter by, definitely you have to go for the duration. Duration is the the last field into the schema, correct? So duration greater than 7200. 2 hours means 1 hour. I mean 1 hour is equals to 3600 seconds. 1 hour is equals to 6 to 6 into 2600. 2 hours means 600 into 2720. We're just checking this particular, and we'll get the outputs. How the output movies between 19 and 1995 will get. So movie starts with D. Movies are starting with the D. Other movies are not started with the movies that is greater than 2 hours. Movies are greater than 7 to more than 720. You're getting this. Now we'll see about the describe. What is a describe? It will describe the schema of a relation. Describe movies means it will tell that movies relation has one field ID which can hold integer, then another field name hold character, another field year which hold integer, another field rating which holds double values, another field duration which holds will describe the relation. Now we'll see the data processing using the for each. For each actually transform a relation. It goes through a relation based on the columns, based on the fields. We use the fields columns interchangeably, rows and tuples. Okay, let's understand this how it happens. So particular relation movies underscore duration. What we are doing, we are using for each generate comes together. For each and generate comes together. For each from the movies that is we are going through the movies from the movies relation we are going through we're applying the transformation into the movies. Yes, based on what name for each movie name duration divided by 60, so it will be into minutes, it will come into the minutes, correct? The movie names is duration into the table. By default it is given in seconds. We're dividing it by 60 to show it to the, and we are forcing it to the double, typecasting for double. Are you clear? Duration is in integer, right? If you divide some integer by 60, then it can be double value also, right? Suppose a movie is having 125 seconds, for example, not ground reality, but for example, it's 125. If you divide by 60, it will be 2 point something, correct? To store that value, you are putting into typecasting to the double integer, forcefully, explicitly typecasted to double. So for each movie name, what you're doing basically in this command, for each movie name, we are displaying their corresponding duration divided by 60. That is, their duration is transformed to the minutes, and the above statement generates a new alias that has list of movies and its duration. It's important. How we see the output? For each movie now, their second wise description of duration is now transformed to the minute wise description. All are all minute wise description of the same table duration, which had given all these things as per what, as per seconds. Was in second, was in second, was in second. All was there in second. Now it transferred to. Now is the next example group. So group key was used to group the data field based on some specific value of the data field. We can group it inside the same relation. Okay, when you use two or more relation, that time you use the co-group. That's the difference between group and co-group. So how we are doing it? Group by. You have to use the group and by comes together. Like for each and generate comes together. Group and by comes together. So group, what you are grouping, we are putting the transformation to the movies by what? But which field? Field is year. So grouped by year will be holding the values of the movies based on year. For each unique year, it will provide you the number of movies, the details, this way, this particular way. For 19, for this 1985, the movie with ID2 name is this, and here is this, and rating is 3.8, and seconds is duration is 00 seconds. Similarly, for 1987, you can see that more than one movies are there into a data set. Movie ID 8 and movie ID 7, the details. Similarly, we have for 2004, movie with ID 10 and movie with ID were there with their details. In this way, we can see that we have grouped it in a certain way. By what? By using group by keywords, by the group by operators. Now, on that output is that grouped underscore by underscore year. Now, on that particular thing, on that particular relation, what you have done, you have put the transformation by using for each and generate words. So for each generate has been put on group by year. Group what? The count the group of the movies. For each group, we will count the number of movies. Count will give the count of a particular things. The movies are provided over here. Now, this is the movies, right? So that will give the count of movies. For each year, it will provide the count of movies. That will be the output. 1985 movie was released. Only in 1980 were released, and 2004 two movies were released as per the table we have. That is being. We have the order by clause. Order by clause will list all the movies in the ascending order of year. So ASC is by default in its ascending order. So you have to use the order and by. Order and by comes together. You are putting the transformation to where? Putting the transformation to movies. Yes, based on which particular row, based on which particular here, which particular field it is. So based on, if you dump it, then you will get movies names, as per the year, ascending order. 1985, then 1988, 1987, 1988, 1990. See this coming now, coming now. How? Terms of ascending order of the movie release. If you do the same thing in descending order, just you have to check the DSC. Yes, it will be DSC will hold for the ascending order. Yes, so it will be opposite completely. This one will come first, then this will so on. In case you use DSC in the order by clause. Similarly, we have the limit. Limit will is very simple thing. It will give a certain limited number of result from a relation only. So limit movies 5 means top 5 movies will be collected from there. From the movies table, it will put the transformation and top 5 tuples or top 5 rows will be selected and it will be stored to the result. Now, if you dump to this result, you can see the top 5 results are only. I hope that this is the basic and very foundational execution of pig processing by using the pig Latin programming language. Hope that you understood all the things, and it will help you out understanding the first. You can go through with the this particular program as a first programming. If you have any doubt, you can put it. Thank you very much.